Welcome back. In this video, we're going to try to find all the z in C such that z plus 4 over z is in R. So here we want to find z, the complex numbers, such that z plus 4 over z is in R. Remember that C is this set, A plus IB with AB reals and I squared is minus 1. Okay, here the first thing that we need to note is that we have this 4 over z. We don't want to have zeros, so we don't want to divide by zeros. Therefore, the first thing that we require is that z must be different from 0. Okay, so this is the first condition that we need to have. The second remark that we need to do is that if z is real, okay, if z is real, that means z is the same as z bar, the conjugate. Okay, this case we have z is different. We must have z different from 0, the real 0. And in this case, we have the sum of two real numbers. So z is real and 4 over z is real. Therefore, the addition of two real numbers is real. Okay? So we see that when we have z is real, we have this automatically. Okay? Therefore, to be able to solve in the set of complex numbers, we're going to assume that z is different from z bar. That means z is not real, because when z is real, the solution is obvious. Okay? Another thing that we need to note is that once we do z equal different from z bar, we need to have z different from 0. This is coming from this condition here. And z different from 0 means that z bar must be different from 0. And this gives us that z times z bar must be different from 0. So the product of two non-zero numbers is different from 0. Okay? So the next step is how to find the numbers z in a C that would satisfy this condition. Okay, there is there are two or three ways, or 4 ways at least, to solve this problem or to find these numbers. Okay, one quick way is to let z be a plus ib and solve. And once we solve, once we plug the z here, we need to have the imaginary part be 0, and we can proceed and solve and find the numbers that we need. Okay, but we're not going to do that. You can proceed in this manner by yourself. You can do that. Okay, so you can plug z and 1 over z and manage to do the algebra. And once you do that, you will have this form a plus ib. And to be able to solve, you need to set b 0. Because when you have this one, that means you have this one real. And from here, we can find the conditions on b and a, and we can find z finally. But we're going to proceed in a different manner. We're going to let z, big Z, to be z plus 4 over z. Okay? And we know that a number, a complex number, is real if and only if its conjugate is the same as itself. So here, this means that z bar must be equal to z. Okay? So once we do that, okay, with this condition, we have z is different from 0 and z is different from z bar. Okay? See the previous part of the video to see why we have these conditions. Okay, so once we have that, we can proceed and solve. Now z equals z bars means what? Means the small z plus 4 over z is z bar plus 4 over z bar. Okay, I have used the fact that z plus 4 over z bar is z bar plus 4 over z, the conjugate of 4 over z, which is 4, the conjugate of 4 is just itself over z bar. Okay, here we use the fact that z over z bar conjugate is the conjugate of z1 over the conjugate of z2. So this result here. So I've used it here, okay, for those who wanna step-by-step solution. Okay, so now I'm here. Okay, what can I do here? I can just solve now. So now I have z minus z bar is 4 over z bar minus 4 over z. I'm gonna factor out by z minus z bar over z bar times c. Now I can use the fact that z different from z bar, that means z minus z bar is different from 0. Okay, therefore I can solve here. I can factor out by z minus z bar and divide by z minus z bar to get 1 is 4 over z minus z bar. Okay, now here this number is not 0 according to what we said earlier. Okay, so this means that z times z bar is 4. But using the definition, this means that this is just the modulus of z squared is 4. That means the modulus of z is 2. So this is always real. Okay, it's always positive. We don't accept the negative values. Okay, that's why you have only 2. So once I'm here, okay, this means that my z can be written as z is z bar or z, the modulus of z e I theta with theta real. Okay, that means z is 2 e I theta. Okay, so I found the z. I need to add this condition, z is different from 0. Okay, another thing that I need to do is I need to check that under this condition here, that the solutions that I found will be in R. That means z plus 4 over z will be in R. Okay, that's what I'm gonna do here. So I found that z is 2 e I theta. So here I'm gonna have z plus 4 over z. Does it belong to R if I have this condition? Okay, let's see. So z is 2 e I theta plus 4 over 2, which is 1 over e I theta. I can simplify, so I get 2. I'm gonna factor out by 2. I have e I theta plus, I can multiply top and bottom by the conjugate. So I'm gonna have e minus I theta over e I theta times e to minus I theta. So this is just 1. So I have 2 e I theta plus e to minus I theta. But this is just what? This is just 2 cosine theta. That means this is 4 cosine theta. And this is always real since theta is in R. Okay, so this is in R. So I checked that this works. So once I found z in this form, that means I found all the solutions and I can graph them. So I can graph these numbers here. So I know that these numbers, the origin is not part of the solution. So the numbers, this is 2, all these numbers here. So this is the circle centered at 0, 0 and having radius 2. Okay, so any theta for any theta in R. Okay, so this is the set of solutions for this problem. What can I say? What else? The last thing that I would say is that if we proceed in using this z is a plus ib, we would definitely get the same solutions. I would highly advise you to do that. Okay, we don't want to do that here, so we have used this fact here. So this is we didn't prove this one here. So that a number is real if only if it is equal to its imaginary or its conjugate number. Okay, we can prove it, or I can give a sketch of that before we finish. So a number z can be written as a plus ib. So this is a real number if and only if z is z bar. So here, if z is real, that means z is that means that b is 0, and that means z is just a, and a is real. Okay, if z is z bar, that means what? That means a plus ib is equal to a minus ib, and we solve, we get 2ib is 0. That means b is 0. That means z is real. Okay, so this is a quick proof of this result here that we have used. If you see any errors or mistakes, please let me know. I have skipped many ideas. I'm assuming that you have some knowledge of the complex numbers. If you don't have a deep knowledge of the complex number algebra, that means the beginning of the algebra in complex numbers, please let me know, and I can go back and explain anything that we have missed. If you see any errors or mistakes, please let me know so we can fix it. Thank you very much.